Okay, hi everybody. We're going to be doing coordinate proofs using distance with segments and triangles today. This is section 10.3 in geometry, section 2.3 in math 3. So go ahead and open your book up, and we're going to take a look at this problem. So taking a look at our distance formula. Where does our distance formula come from? Well, it actually comes from, it comes from Pythagorean theorem. So you guys are familiar with Pythagorean theorem as a squared plus b squared equals c squared. I'm going to rewrite that slightly. I'm just going to put the c squared first. And then if I take the square root of both sides, I get c equals the square root of a squared plus b squared. Well, why is that helpful? That is actually the exact same formula that shows up right here. JK would be C, and A and B would be the two other legs. How do I find the length of A? Well, I take this x-coordinate, I'm going to make a number up, let's say it's 8, and I subtract the x-coordinate of J, which let's say it's 2. 8 minus 2 is 6, so I've subtracted the x-coordinates of those 2 points. That's how we came up with the distance formula. Now that's all we're going to do right now with that proof. We're going to go ahead and move on down to example 1 and, talk about what we're doing with a coordinate proof, why we use that formula. And let's move on. So first thing is, when we're talking about doing a coordinate proof, we're going to use a little bit of geometry, a little bit of algebra. What this means is we're going to put our shape on an XY graph and use the coordinates that show up on that graph to prove what we're trying to prove. There's a few strategies that will make a coordinate proof easier. When you're deciding to put that shape on your graph, when possible, one strategy is to put one of the vertex, let's say we're doing a triangle, to put a vertex on the origin and a side on the x-axis and keep everything up here in quadrant 1. Why is that a good idea? Well, because it means all of our numbers are positives, so we don't have to deal with any negatives in our equations when we show up. Another option, especially if you have something that has a line of symmetry, where you could fold it in half, is to center the figure on the origin. So if I take that triangle, maybe I draw that triangle this way. So it's centered on my origin, and if I've got two pieces that are equal on either side of that y-axis. And you notice I did this in both situations. I put one of my sides on the x-axis. If you have a right triangle, definitely put the right angle at the origin, and then you can put two sides on an axis. Just makes those completely horizontal or completely vertical side is a lot easier mathematically to deal with. So let's take a look at this first example that they've done for us. We have the coordinates. They told us angle B is a right angle and D is the midpoint of AC. So because that was a right angle, they put angle B for this triangle on the origin. That meant that A could go up straight, BC could go completely horizontal. When I connect them, the last point they told us was that D is the midpoint. And if you'll notice, there's these two little tick marks. That tells me that that segment AD and this segment DC have the same measurement. They're equal. So they've set that up for us. What they wanted us to prove then is that the area of triangle DBC is 1/2 the area of triangle ABC. So they gave us the coordinates. Why did they double them? Well, that's going to make it easier to cut in half. So let's take a look. If D is halfway between A and C, well, horizontally, the full length horizontally is 2n. So halfway would be just n. Vertically, the whole distance is 2j. So halfway would just be j. So we have the coordinates for point D. It's nj. Let's take a look at our area formula. So we know area of a triangle is 1/2 base times height. So we're going to plug in for triangle ABC, 1/2. My base is the length from 0 to 2n, so it is 2n. And my height is the length from 0 to 2j, so 0 to 2j, that is 2j. Let's work that out. We've got 1/2 times 2n is going to give me 1n. So I've got n times 2j becomes 2nj. That's the area for the big triangle. I'm going to switch to blue here and do some erasers. The other one they asked us to find was the area of DBC. Well, DBC is this triangle here. And let's take a look at its area. So same formula, 1/2 base times height. So 1/2, the length of my base is still 2n. My height, however, is the y-coordinate of D, which is j. So if I simplify that, 1/2 times 2 is just 1. So I've got nj. If I look at that, did I prove what they asked me? Is nj half as big as 2nj? Well, it is, because another way of saying DBC is half of ABC is saying that ABC is twice as big as DBC. And since there's a 2 in front of it, we know it is. All right, we're going to stop there, and I will see you in class tomorrow.